Okay, so let's look at a question like number 3. You want to have $307,000 when you retire 30 years for an annuity. How much money should be deposited at the end of monthly in an investment plan that pays a 4.2% compounded monthly? So you will have the $307,000 in 30 years. Okay, so we are going to use our savings annuity formula, and let me write that on here. So here's our formula. Let's identify everything that we have. Now, we want to have $307,000. That's going to go over here on the left side of the equation. Our 30 years is going to be our capital N, the number of years. Monthly is 12 times per year, so that's going to be our K. And then 4.2% interest rate will be our R, but we'll of course list that as the decimal 0.042. So let's plug in and let's chug through this. So let me move the window a little bit so we got room. Okay, so if we put the 307,000 on the left side of the equation, and we don't know how much we're going to deposit, so we're going to have to solve for D, but let's fill in the rest. And I may have the problem of running out of the window again. Let's see if I can move that. There we go. All right, so we will have 1 plus R is 0.045. We said we're going to compound monthly, so that's 12 times. All right, and raised to the 30 years times 12. Oh, I'm sorry, I was looking at 2 for the 4.5. It's 4.2, so this is, let's see if I can get the eraser here. Let's see if we can fix that. 4.2, so 0.042. Don't want to confuse you there. Times 12. Here, minus 1, all over R 0.042 over K12. And I'm going to go off the page to put my parenthesis over there. There we go. All right, now let's work through this. All right, so now I've got 307,000. First thing we want to do is the inner set of parentheses. So 1 plus 0.042 divided by 12. I'll put that in the calculator. So that gives me 1.0035. And that's raised to, I'll go ahead and multiply the 30 times 12, 360. Just for the sake of space, I'm just going to put a line here so we're not running up against this stuff. Minus 1 all over. Now I can also do this computation, and this right here is going to be this decimal without the 1, so 0.0035. All right, now next, we've got to do this number raised to the 360th power. So we'll do that in my calculator, but first I'll rewrite this. So 1.0035 to the 360th power. And we want to keep as many decimal places as we can for accuracy, so I'm going to keep everything that my calculator gave me, 3.51767 4548. we don't put all those decimals there, we will be off and the answer gets counted wrong. So we're still subtracting 1 over this. All right, so next I'll go ahead and subtract 1 on the top. So I'll have 307,000. 3.517 blah 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 minus 1 is just going to be 2.5176,745,48. And then let's finish this division. So we'll have 307,000. And I'll go ahead and put this into my calculator. And I get 719.3355. Again, keeping all my decimal places for now. 852. Now, let's go ahead and solve this equation. So I have a number multiplied times the variable. To get rid of the number that's being multiplied by my variable, I need to divide by that number on both sides. So I'm going to divide by 719.3355852. And of course I'm also going to do it over here. So I'm going to put that into the calculator over here. Of course, this is going to cancel out. We're going to have d by itself. So we'll have that our deposit amount is whatever this ends up being. And we get $426. And now I can round off to the cents. So I'm rounding off. I've got 0.782, which will round to 0.78. So $426.78.